All right, so now we're going to look at some more inequalities in a triangle so that we can actually compare the angles when we have a triangle that's split into basically two other smaller triangles. So relationship between angle measures and side lengths in two triangles, we have, we want to order the sides, so CE, EF, CD, CF, and FD from least to greatest. So all kind of the exterior sides, and they did split the bottom. Let's see, did they split the bottom? FD and EF. They did split the bottom because they're looking at the triangle on the right and the triangle on the left and the triangle on the right. So we're going to go through and we're going to kind of split them. We're going to look at them separately. So we're going to look at each angle here. So angle FCD is equal to a certain amount. So we're going to go through and we're going to kind of group these. But first, what we do need to do is, if you notice, we don't have all of our angles filled in. Okay, so let's look at the red one first because I have two angles here. I only have one angle here. So I'm going to fill in this one first and then I can actually fill this one in. So remember triangle angle sum theorem. If I know two angles out of the three, I can find the third missing one because all three angles have to add up to 180 every single time any triangle you've ever looked at. Okay, so I have FCE, which is this top one is 42. I don't know this bottom one, which is CFE. And then I do know the bottom one, which is just angle E. If you notice, I can just label that E instead of using three letters because that's the only angle it could possibly be. If I said angle F, though, it could be this red one or it could be this blue one. Same thing with C. That's why I have to use three letters there so that you know which direction I'm going. All right, so let's add 42 and 85 together. We get 127. And then we're going to subtract 127 from both sides so that we can see what's left over. So now we have this 53 degrees here. Now I can actually go through and start filling in this blue triangle. Okay, so we're just going through, we're finding all the angles before we deal with the inequality part here. So whenever I have a flat line, that equals 180 degrees. So the blue angle here and the red angle here are going to add up to 180 degrees, just like all of the angles of a triangle add up to 180 degrees. So a flat line also equals 180. So I can go angle DFC, which is just the blue side here, plus the 53 degrees, because that's the angle EFC, equals 180. Then I'm just going to subtract 53 from 180, and that'll give me 127, which is kind of funny. It took us right back to the 127 here. That's actually the exterior angle theorem. It would equal the two remote angles added together, which we can see that it does in fact equal the 42 plus 85 added together. So that's just another theorem that we can throw out there. So now we have the 127. So now we're going to do one more time. We're going to do that triangle angle sum theorem because I need that one last angle filled in. Okay, so I have 22 plus 127. So I have two pieces. Here's angle D. Out here, that's the only angle it can be, so we can just label it angle D. And then I have DFC, that's the 127. And then I have FCD. So I don't know what FCD is, but I do know what DFC is, and I do know what angle D is. So 127 plus 22, I get 149. And then 149 minus 180, that gets me 31. So now that I have all the angles filled in, I can go ahead and I can start looking at the inequality pieces here. So I can start saying, you know, what do they equal? And if you notice, I put the in red in here, and I know you probably can't see that on your paper because we print it in black and white, but you can see it on the screen here. The middle is the vertex. So FCD, well, that means I'm looking at C. FCD, this way. FCD, so that's the 31. And then CDF, well, that means I'm looking at D, right, 22. And CFD means I'm looking at F, which is 127. So just kind of a quick way to see which one am I looking at. You just have to know which triangle am I looking at, the blue one or the red one. So we can see it's 31, 22, and 127. So we're just going to put them in order. So which one is the smallest one? Well, that's 22. So that's CDF, right? And then 31 is the next one, which is FCD. And then the largest is that 127, which is CFD. So now that I have these in order, I can start to look at the side lengths because it's opposite those side lengths. So opposite angle D for the blue triangle is going to be the smallest side, which is CF. Okay. the side opposite angle C for the blue triangle, that's going to be the kind of medium length. That's going to be the one in the middle. And then the largest side is going to be opposite that 127, which is opposite that angle F. Okay, so now you can see it's CF is less than FD is less than CD. So I've put these in order. So now I'm going to do the same thing for the red triangle here. And again, I did that red thing in the middle so that you can see. So angle C, so that's 42 degrees. Angle E, if I went down here, that's 85 degrees. And angle F, that's 53 degrees. I think it just makes it a little easier if you kind of focus on that middle. As long as the middle term is the vertex, we can definitely focus on that a little easier. All right. So now we're just going to put them in order. So it goes 42, then 53, then 85. So ECF, then EFC, then CEF. So again, now that I have the angles in order, I can put the sides in order. So opposite ECF, which is C, is going to be the smallest side. So that's FE. Opposite the angle F, that's the next largest side, is EC or CE. And then the largest side is going to be opposite that 85, which is CF. So now we can see them in order here. EF, CE, CF. So what I need to do now, if I want to put them all in order from least to greatest, I kind of need to line them up. So you can see I gave you that option here so that you can see that this one begins with CF. Well, this one ends with CF. This is the largest angle here. It's the smallest angle in the blue, right? So if they line up like this, what you can do is you just kind of merge them together. So that we have EF is smaller than CE is smaller than CF is smaller than FD is smaller than CD. So CD is the largest, FE is the smallest side. All right, so this is the relationship between angle measures and side length in two triangles. I hope that helped, and I will see you in the next video.